Today, we're going to dive into a really powerful idea, one that connects something as ancient as a trilobite's eye to our own possible future out there among the stars. And it's all built on one single rigorous concept, that reality itself sets an exam.
So here's the core metaphor. I want you to imagine reality as this completely unforgiving examiner. It's not a conscious being, not at all, but a relentless process. And this exam, it only tests one thing. Is an organism's internal model of the world good enough to keep it alive? The grading is brutal. It's simple. You pass, and your lineage gets to continue. You fail, and it ends. Period.
Okay, so what does this exam actually test for? Well, over billions of years, natural selection acts like this incredibly fine-grained filter. It ruthlessly, and I mean ruthlessly, eliminates any lineage that consistently gets the world wrong in a way that actually matters for survival. And this, right here, is the fundamental rule of the exam. It's not about having some perfectly true picture of reality in your head. It's about having a model that is good enough at predicting cause and effect. You know, an antelope that misjudges a lion's speed or a bird that miscalculates the location of a branch, their models fail, and that failure is final. And what's amazing is you can see this principle in action across completely different species. A bat, for instance, uses sound waves, echolocation, to map out 3D geometry. An ancient trilobite used these incredibly sophisticated calcite lenses to navigate using polarized light. The sensory systems themselves are totally different. But here's the thing. Physics forces them to preserve the exact same underlying structures of reality. Things like geometry, object boundaries, the properties of waves. Their internal models have to converge on the truth because the exam is the same for everybody.
This whole process reveals a really powerful asymmetry right at the heart of the exam. If you systematically fail to model reality correctly, it is a guaranteed death sentence over deep time. But, and this is so important, modeling reality correctly does not guarantee your survival. A perfectly adapted species can still get wiped out by a random asteroid. So success isn't assured, but systemic failure is.
All right, let's try to formalize this idea a little bit. What does it really mean to track reality? And, maybe more importantly, how does this whole framework hold up against some pretty common scientific objections?
Well, the paper defines it in 3 key ways. First up is causal adequacy. Basically, when you do something, the result you predict is the result you get. Second, information preservation. Your model has to capture enough data to tell the difference between something that's safe and something that's lethal. Pretty important. And third, invariant preservation. Your model has to respect the fundamental physical laws. I mean, you can't have a working model of the world that just ignores gravity and expect to survive for very long.
Now, this is a very sharp question, and a totally fair one. If we're defining a good model as one that helps you survive, and then we turn around and say, well, the survivors must have had good models, it kind of feels like we're just talking in circles, that we haven't actually explained anything at all.
But the paper offers a way out of this loop. We can break the circle by measuring something else, something independent. Control error. Just think of it as the gap between what an organism's model predicts will happen and what actually happens. A model that consistently messes up its gravity calculations is going to accumulate control error way faster than one that gets it right. And we can measure that error before we even know who lives or dies.
So this all leads to the philosophical payoff, a position called modest structural realism. And the idea is that evolution doesn't guarantee our senses show us the ultimate nature of things, what reality is, but for survival, it absolutely must guarantee that our models reliably track the relationships and the causal structures that matter. Honestly, it's why science works. Not because it reveals some ultimate capital T truth, but because it successfully maps the rules of the game.
And think about it this way. Our brains did not evolve to calculate orbital mechanics or to design antibiotics. The fact that the very same cognitive tools, just extended by math and science, can build a GPS satellite that actually works, that is incredibly powerful evidence. It shows that our models have captured real generalizable structures of the universe, way, way beyond the survival needs of the African savanna. Okay, so if this logic holds true for all life, and the laws of physics are the same everywhere in our corner of the universe, then how could we ever compare ourselves to a completely alien intelligence? Well, the paper proposes a kind of universal final exam, interstellar travel. And just to appreciate the scale of this exam, just consider the energy cost. We're talking 250 terawatt hours. That is the bare bones minimum kinetic energy, just to get a 1-ton probe to 1/10 the speed of light and then bring it to a stop. To put that in perspective,
That's roughly half of Germany's entire annual electricity production for one small probe. This isn't just an engineering problem, it's a civilizational one.
And it's not just about energy. Interstellar travel is this insane bundle of challenges that you have to solve all at once. You need that massive energy source, sure, but also a way to propel your craft, shielding that can survive a dust grain hitting it with the force of TNT, and autonomous navigation that works perfectly over centuries. You can't cheat on one part to solve another. Every single one of these is pass-fail.
So all of this brings us to the central insight of the paper, the really profound but also strictly limited conclusion we can draw if we're ever visited.
Look, if a craft arrives here from another star, its very presence is an irrefutable demonstration of its creator's mastery over energy, propulsion, and long-duration engineering. It is an existence proof, but that is all it proves. It tells us absolutely nothing about their morality, their intentions, or their wisdom. It is a statement of capability, not of character. So if you think about the Fermi Paradox, an arrival would be the ultimate Bayesian update. It's a single piece of evidence that would force us to dramatically revise our entire understanding of the cosmos. You know the great filter, this idea that there's some massive hurdle that stops life from becoming interstellar? Well, an arrival would prove, with one single data point, that the entire filter is passable. It would change the question from, can it be done, into a fact.
Now, what makes this whole argument so compelling is that it's not just philosophy, it's not just navel-gazing. This framework is designed to be a real scientific theory, which means it makes predictions that we can actually test and potentially prove false.
The paper's big claims really boil down to three core testable hypotheses. First, that any form of life that sticks around for a long time has to be tracking causal structure. Second, that having a more accurate model, what the paper calls lower control error, directly predicts longer survival times. And third, that any interstellar visitor, no matter who they are, must have met a specific, calculable minimum energy requirement to get here.
And this isn't just a thought experiment. It actually opens up a concrete research program. We can test if the flight mechanics in bats, birds, and insects all converge on the same Newtonian principles. We can use our amazing astronomical surveys to place real upper limits on how much interstellar traffic is out there, if any. We can even run evolutionary simulations and see if artificial agents selected purely for survival in a physics-based world independently evolve to track that world's causal structure.
Ultimately, this whole framework completely reframes the question of first contact. The arrival of an alien craft wouldn't really be about discovering who they are. The most profound lesson would be the quiet, empirical demonstration of what the universe permits. It would answer, once and for all, what is possible.